Hello, Michael again, and we have received our parcel. So hopefully we have our MOSFETs in there. Yes, here we go. I've ordered 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've just got a couple of spares just in case. So, time to pop them in. Alright, so I've got these MOSFETs from Element 14. They're a N channel, 500 volt, 20 amp, a TA's 247 package. And let's pop them in and see how we go. So we've got one side done. Let's clean up the flux. And I'll inspect, make sure that all my solder joints are good and there's no dry joints in there. And if it looks good, then I'll go on to the other side. If not, I'll resolder or reflow. Yeah, could do with a bit of solder there. A bit of solder there. Otherwise they look good. Let's just flow a bit of solder into here. That's a bit of solder taken off another component from when I desoldered the MOSFETs from the circuit board. Then use the solder removing station. Yeah, I've just taken a bit too much extra solder off, but anyway, reflow all that. And we should be happy. It's looking good. Give that a bit of a clean. That's done, that side. Let's clean that up now. And as with the other side, we'll inspect our soldering. Yep, all looks good. So happy with that. There we go. I'll flip it over. So we'll need to give the MOSFETs a bit of a bend inwards gently. So they're sort of in the same line as the circuit board. Just gently bend it over. That's why I got a couple of extra ones, just in case I happen to break one. Okay. Happy with that. Take that out of there. You just notice this heat sinking mat is bounded up. Just do it on both sides. I'll remove it and I'll replace it back in. Done the same thing on this side. Right. Push this in place. So, just get that lined up there with the glue, and also the circuit board should be flush on this RJ45 socket, so we can really have a bit of heat shrink rubber back behind these transistors. Bend them out a bit. Try and get them so they're over the holes, like so. We'll get our plate. Screw in for that. I might just speed this up a bit. screws back into place except for the bottom cover. Just power it up and see what happens. See if we can let some smoke out or see if it actually works. I'm just going to use the bench power supply for the moment because it's limited to its current. So if this thing draws too much current, it just drops. The current limit just drops in. So we'll put that on our positive, this one on our negative, and power. Okay, well the fault light's gone out. That's a good start. Fault light's not on. Just plug something in and see what happens. We'll try the soldering iron. Unplug that from there. Plug it into here. Let's doing a bit of strange behaviour. Let's just see what the voltage is out on the outlet. AC. All the LEDs won't lighten up on the soldering iron. So we've only got 174 volts. Our voltage is a bit low. Or that could be because our power supplied to the battery terminals is a bit low. Let's put a battery on there. Okay, so now we have the heavy duty battery leads connected to a fairly beefy battery. It's a 125 amp hour 12 volt battery, usually found in remote repeater sites. So it's a fairly beefy battery, although this battery has passed its service life now. It's no longer able to be in a remote repeater site, but that's okay. It should work for this experiment. Current surface voltage on the battery is 13.17 volts. I've got the Fluke 23 plugged into the AC power outlet, and let's see what we get now that we're running off a battery. Okay, so we've got 191 volts AC. Surface voltage is still running around 13 volts on the battery. Let's plug a soldering iron station into the other socket. It's still a bit low on the voltage on the AC. Okay, so the voltage has come up now that we've turned the soldering station on. Our 12 volts, our 12 volt power battery has dropped to 12.79 volts. So we've got 210 volts there. And we've now actually got the lights displayed on the soldering station, whereas before the LEDs were not displaying properly. The one that was running off the bench power supply. Okay, well that seems to be working. Let's plug something in a bit more heavy on the power. This one, the soldering station puts out about, it draws about 45 watts. Let's try a heat gun. A heat gun's going to draw 1500 watts on the highest setting, and I don't know what the lowest setting is. It doesn't say what the lowest setting is, but 1500 watts is what this inverter's rated at. So it'll probably kill the battery if I try to draw too much power out of that. We'll just run it on the lowest setting. So what have we got? 213, 12.6. Plugged the wrong thing in. Try plugging this one in. Okay, here we go. Lower setting. The voltage has come up to 235 volts AC, and our battery voltage has dropped to 11.25 volts. Do I attempt fate and go for the full 1500 watts? Yeah, 1500 watts. We're running down, the battery's running down to about 10.5 volts. The system's going to shut down soon because the battery voltage is getting too low, but we've still got 130 volts AC, and the battery voltage is seems to be semi-steady at about 110.5 volts DC, but this thing's designed to shut down after the battery voltage gets below 10 volts. So we won't stress it out too much. We know it's working, and nothing's getting hot, and I haven't let any smoke out. So I think that's a fix. So I hope you enjoyed that, and if you liked it, please like and subscribe, and we'll see you on the next one. Cheerio.